Here we have a unit circle, center 0, 0. And here we have a radius of that unit circle from the origin to the point 1, 0. If you look on the left hand side, we have a blue slider. At the moment we have b equal to 0. And if I move the slider, we'll see what it's changing. And the slider is changing the radius. This number is the angle in radians between the x-axis here and the radius. As I move the slider up, we'll see the radius changing. In fact, each of these increments in the angle is equal to 10 degrees, but I'm working in radians, so that will be pi divided by 18. If you look to my first increment, we see it's about 0.175 radians. As we move the slider, the point the radius makes through the circle is given here, and at this point we can see the coordinates of the point. Remember from a previous lesson, this first coordinate, x, represents cosine and y represents sine. So as I move my slider around or up, I can see the angle changing and the coordinates for each of these points, and therefore I can read off sine and cosine. Of course, I want to be able to record all these coordinates, and in GeoGebra I have a function which allows me to write these coordinates into a spreadsheet. What I do, I go to View. On the drop-down box, I click on Spreadsheet View. What we see here on the right-hand side is a spreadsheet. This spreadsheet already has the angles or the increments of b written in. So starting at 0 radians, we're going up by 0.175 approximately every time, which again is equal to pi divided by 18 radians. Now, I want to write in the coordinates into the columns B and C. In order to do that, I right-click on the point, and on the drop-down menu, I go to Trace to Spreadsheet. And at there we can see the coordinate 1, 0 written into the spreadsheet. The next thing I'll do is start to move the slider, and as I move the slider, I'll get the next point written in. So I've gone up by one increment. I've set this at, as I said, 10 degrees or pi by 18 radians, and here we have the coordinate written in. I'll keep running through. In fact, there we are there. I've gone through a quarter of the circle, and we've got to the point 0, 1. I'll continue to move B up the slider. Here we are at half a circle. In fact, the slider is indicating this as pi, which of course it is. And I'll keep going all the way down to 2 pi. What we now have recorded is for each angle the value of the x-coordinate and the y-coordinate. Of course, what's important here is the x-coordinate represents cosine and the y-coordinate represents sine. It is these values which will allow us to graph both f of x equals cosine x and f of x equals sine x.